Hello, everyone, and welcome back. Today, I'm going to be talking about conditional statements, converse, inverse, contrapositive, biconditional, what the difference is, and some examples. So let's dive in. Conditional statements. What are conditional statements? Conditional statements are statements that follow this format: P, then the arrow, and then Q. And when it's read aloud, it's read as if P, then Q, or P implies Q, where P is the hypothesis and Q is the conclusion. For example, let's say P is two angles summed to 180 degrees, and Q is they are supplementary. That means we can say if two angles sum to 180 degrees, then they are supplementary if we were to make a conditional statement out of these. And in this case, we know that that is true, right? We understand that if two angles sum to 180 degrees, then they are supplementary angles by definition. So that's the idea there. Now there's another example here. Let's say P is a triangle is equilateral and Q is a triangle is equiangular. What would the conditional statement be? I'm going to give you a moment to pause and think about what that conditional statement would be, given what we just learned, that all conditional statements go if P, then Q. Okay, let's take it up. So this one would be if a triangle is equilateral, then the triangle is equiangular. All right, key here is if P, then Q, right? If hypothesis, then conclusion. All right, let's move on to the converse. The converse of a conditional. The converse of a conditional is where we switch the hypothesis and conclusion around. So instead of if P then Q, like we had for our conditional, it's now if Q then P or Q implies P. So let's take that first example from before, where P is two angles summed to 180 degrees, and Q is they are supplementary. Here we would say if Q, right, if the two angles are supplementary, then P, then they sum to 180 degrees. Another example with P being a triangle is equilateral and Q being a triangle is equiangular would be if Q, so if a triangle is equiangular, then P, then it is equilateral. Very good. Now, something I want to mention is that just because a conditional is true doesn't necessarily mean its converse is true. And just because a converse is true doesn't mean a conditional is true. But there are cases like these where both the conditionals and the converses were true. And that's what's known as biconditional statements. Biconditional statements are statements where both the conditional and the converse statements are true. So for example, P, a triangle is equilateral. Q, a triangle is equiangular. The P implies Q and Q implies P are both true. Therefore, the statement is biconditional. We know that it's true that if a triangle is equilateral, then it is equiangular. We also know if a triangle is equiangular, then it is equilateral. And we also know that if a triangle is equilateral, if and only if the triangle is equiangular, right? If we look at a triangle and we see it's equilateral, we can automatically jump to that conclusion, okay, it's equiangular. And vice versa. If I see a triangle that's equiangular, I can automatically just jump straight to the conclusion that it's equilateral too, based on these statements and the fact that they're true. However, not all statements are biconditional. Just because a conditional is true does not mean that the converse is true, and vice versa. Just because the converse is true doesn't mean the biconditional is true. So for example, let's say that P is an angle is 80 degrees and Q is the angle is acute. Our conditional would be if P then Q. If the angle is 80 degrees, then it is acute, right? And that is true, right? We know that an acute angle is from 0 to 90 degrees, or I guess, from 0 to 90 degrees, not including 0, not including 90, because 90 would be a right angle. And so since 80 degrees is between those numbers, therefore it is acute. So we know the conditional statement is indeed true. However, let's take the converse where we switch them, right? That would mean we would have if an angle is acute, then it is 80 degrees. And this is not necessarily true, which is why it's highlighted in red here. This is not necessarily true. Just because an angle is acute does not necessarily mean it's 80 degrees. It might be 80 degrees, but maybe it could also be any other number of degrees from 0 to 90, not including 0 or 90, right? It could be 32 degrees or 64 or 58 or 21 or any other number of degrees that's within those values. So this is not true. Therefore, the biconditional statement is also not true, right? This statement, this P and Q, cannot make a true biconditional statement. If we were to put the statement in biconditional form, it would say a triangle is 80 degrees if and only if it is acute. And this is not true, right? A triangle, we could provide a counterexample and argue that no, that's not actually the case. A triangle could be 30 degrees and be acute. And so just because a triangle is acute doesn't automatically make it 80 degrees. It maybe is, but it maybe isn't. Okay, let's move on to the not symbol. Not is denoted by this little squiggly line here, and not is used to negate a statement. And we're going to need to learn what not is in order to get into inverse and also into contrapositive, which are the next two that I want to discuss here. So here's an example. Let's say that P is it's raining today. Not P would be it is not raining today. If let's say P is I have $5 to spend at the candy store. Not P would be I do not have $5 to spend at the candy store. Let's say P is a right angle has 90 degrees. Not P would be a right angle does not have 90 degrees. Now notice whenever we use not, if the original was true, the not would be false. And if the original is false, the not would be true. There's not really any in between value where both of them could be false or both could be true, right? In the last case here, we know that it is true that the original statement P was true, that a right angle has 90 degrees, and that the opposite of that, to say that a right angle does not have 90 degrees, would be false, right? That is not correct. Or even going back to the example of it is raining, right? Let's say it is raining today. Let's imagine for a minute that that is true. Although I don't think that is true for me, but let's say that that is true, that it is raining today. Well, then it would not be true that it is not raining today. That would be untrue, right? Or let's say it is raining today, or that it is not raining today, that that is true, right? Which I do think that's the case. That's true for me, that it's not raining today. Well, then if I were to then say that it is raining today, well, that's false in the case that not P is true, right? Now, maybe with the raining one, maybe that's a bad example because people could be in different regions. Maybe in one place it is raining and another it's not. But assuming we're talking about one person who's in one region, either it's raining today or it's not raining today, and there's not really an in between. Same with the I have $5 to spend at the candy store. Either that is true or it is untrue, right? It can't be simultaneously true that I do and do not have $5 to spend at the candy store. Either I have the $5 to spend at the store or I do not have the $5 to spend at the store. And so if one is true, the other is false, and vice versa. Now let's talk about the inverse. The inverse is defined by not Q implies not P, or can also be described as if not Q, then not P. So here's an example. Let's say P is it is raining, then Q would be I will bring an umbrella, right? So again, let's review what not P and not Q are. So not P would be it is not raining. Not Q would be I will not bring an umbrella. And for the inverse statement, we're going to find not Q implies not P, or if not Q, then not P. So if not Q would be if I will not bring an umbrella, then not P, then it is not raining. And that's likely true, right? If I don't bring an umbrella, then maybe it's because it wasn't raining that day, perhaps was the case. Now, another note here is that the inverse is true if and only if the converse is true, right? So basically, if we prove that the inverse of something is true, that means the converse is also automatically true as well, and vice versa, right? If the converse is true, we also know the inverse is true automatically from that. And so, one way to prove something, for example, let's say we're trying to prove that a converse is true, proving that the inverse is true also proves that the converse is true. That is one type of proof we could do. We'll get into proofs later. For now, all we need to know is that if the inverse is true, then the converse is true. If the converse is true, then the inverse is true, so it is biconditional. And also, if one of them is not true, then the other is not true as well. Now let's talk about contrapositive. Contrapositive is defined by if not P, then not Q, or not P implies not Q. So let's go back to our example about raining and bringing an umbrella, where P is it is raining and Q is I will bring an umbrella. That means not P would be it is not raining, and not Q would be I will not bring an umbrella. So not P implies not Q would be if it is not raining, then I will not bring an umbrella. Now keep in mind, the contrapositive is true if and only if the conditional is also true. So let's say we're trying to prove a conditional is true. Proving that its contrapositive is true is enough to say, okay, the conditional is true. Or vice versa. Let's say we're trying to prove a contrapositive and we prove the original conditional, then we have proven it's true. In fact, proof by contrapositive is a type of proof. You can look it up. It is a specific type of proof that people do sometimes in certain situations, because in some situations it may be easier to prove a contrapositive than an original conditional, and proving a contrapositive does prove the conditional as well. And let's think about that, right? Let's think about that with this example. The conditional here would have been if it is raining, then I will bring an umbrella, right? And so, therefore, if it is not raining, then I will not bring an umbrella, right? That makes sense. Those are the same statement that if this is happening, then I'll bring an umbrella. If it's not, then I will not bring an umbrella, right? That makes sense. That those two things are really the same. All right, well, that is everything for today. I hope this helped you learn the difference between the different symbols and also what a contrapositive, inverse, converse, and conditional means. And I will see everybody next day. Bye, everyone.